Good evening. In our web series, continued with our combinational circuits. In the previous session, we discussed about multiplexer and demultiplexer, and in this session, we are going to discuss about encoder and decoder, which is also a combinational circuit. So in multiplexer and demultiplexer, we have input and output like 2 power n is equal to n output. Vice versa of multiplexer is our demultiplexer. Here in encoder, we have different aspects like the binary values are selected in active input, and the same reverse operation of encoder is said to be as decoder. What else the issues in encoder can be solved in our decoder. So this is a encoder block diagram. Here 2 power n input is equal to n outputs. You can see the block diagram here. 2 power n inputs. Your inputs are 2 power n, right? Your inputs are 2 power n, and your outputs are 2 n outputs. We have n outputs. So input also 2 to the power n, and output also we have certain discrete continuous like n outputs. Okay. So as per our concept of encoder, we have 4 inputs and 1 output, and this is said to be as 4 to 2 encoder. So 4 cross 2 encoder means we have 4 inputs and 2 outputs. So 4 inputs are considered as y0, y1, y2, y3, and outputs are A, B. So these are all the inputs and outputs. So our inputs are y0, y1, y2, y3, and outputs are A, B. So this is as per our encoder circuit. Here we have 2 types of encoders which comes under priority encoders, and in this priority encoders we have 2 types like odd priority and even priority. So priority means, what does it mean? Priority means the most priority, that is the highest or the best, which is to be considered primarily, right? So that is said to be priority here. So one input, if one input is active, the higher order input will be the lowest order input. So this indicator D is included to indicate whether or not it is valid. The output is invalid when no inputs are active. So D is equal to 0, D is equal to 1. The output is valid when at least one input is active. So that will be considered as priority. Okay. So in this priority encoders, we have 8 inputs and 4 outputs. The least bit is LSB and the most significant bit is MSB. So from A to D, D is considered to be the LSB and A is considered to be the MSB. So we have 8 inputs like Y0 to Y7, Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7, and A, B, C, D are our outputs, which is just an 8421 code of 4 variable. We know very well that truth table is given in our output, and let us see how the inputs are calculated. Like the priority first is given from Y7, then the second place of Y6, then Y5. So in multiplexer and demultiplexer we had diagonal in the output. Here we have diagonal in our inputs. Diagonal inputs in our encoders. Okay, this is the truth table of priority encoder. So in this priority encoder, as I said, there are 2 types. One is odd priority and even priority. Using an n output decoder, it is used to realize a logic circuit for a minterm, n type of minterms, which is shown in the truth table for the function, where the sum or and the corresponding outputs is considered. So this is for each minterm in the minterm expansion of the function or the corresponding outputs of the decoder. So we can leave the remaining outputs of the decoder, which is unconnected. So using an n output decoder, we can solve one problem. See, this is an example problem which is used to solve using 3 to 8 decoder. So you have to design a logic circuit to realize the following Boolean expression, like f of ABC is equal to summation m 2 3 5 6 7. This is a sample problem which we are going to work it out. Okay. So likewise we have another problem. So this is all about our encoder. Thank you.